Today we're just going to go over a few things to do with graphs. A rectangular coordinate system. You've got your x-axis, which is along here, and your y-axis is the vertical axis. The origin is the point in the very middle. Positive numbers are to the right or up, and negative numbers are to the left or down. Each point has the ordered pair x, y. So if we look at this graph, the point 2, 3 would be the x coordinate of 2 and the y coordinate of 3. So it would go right there. So for this example, it asks us to plot the point -2, 4. So we just go on the x-axis to the left to -2 and the y-axis up to 4, and there is your point. Then plot the point 4, -2, so x-axis to 4, y-axis to -2, and there's that point. You can graph an equation using points. Any solution to an equation are the points that work for that equation. So you can plug in an x value and find a y value, or you can plug in a y and find an x, whichever is easier, and that gives you the points for your function or for your graph. In this case, we're going to graph the absolute value of x plus 1. So we're just going to plug in and find some points that will work. So the first point, we're using the x value -4, so we just say the absolute value of -4 plus 1. Well, that's the absolute value of -3, which is 3. So we can go over here and plot that point. Oh, I've already got them written for me, so we don't need to worry about that. Okay, so next, the absolute value of 3 plus 1, that's the absolute value of -2, which is 2. Let's do one more of these. The absolute value of -2 plus 1 is -1, the absolute value of -1, which is 1. So the absolute value of -1 plus 1 is 0, and the absolute value of 0 is 0. 0 plus 1 is 1, and the absolute value of 1 is 1. 1 plus 1 is 2. The absolute value of 2 is 2. 2 plus 1 is 3. The absolute value of 3 is 3. So we'll come over here and plot those points. We've got -4, 3. -3, 2, -2, 1, -1, 0, 0, 1, 1, 2, and 2, 3. And so those are the points that make our graph, and we can connect the dots. And we can see that we've just graphed the absolute value of x plus 1. Some graphing utilities that we'll use in this course are your graphing calculator, Texas Instruments graphing calculator, or we may use some online graphing calculators such as Desmos. But this is looking at, if you've got a graphing calculator, what does the viewing window mean? So for example 3, if you've got this here, -100, 150 by -100, 110, what does that mean? Okay. Well, the first -100 here is your x minimum, and then this is your X maximum. So you have your X minimum of 100, your X maximum of 100, and the 50 is the scale. Now, what is the scale? That is how many units will there be between each mark. So when your graph is marked, it'll look like this will be 50, the next one will be 100, the next one will be 150, like that. Okay, so what does that mean? That means the X values are graphed between negative 100 and 100 with a scale of 50. And then next we've got the Y values. So we've got negative 100 to 100 with a scale of 10. And you can see that over here. So the Y values are graphed between negative 100 and 100. With a scale of 10. And so this is what it would look like. Yeah, not exactly. I don't think my graph's very good here because the marks aren't right. So anyway, the scale isn't correct. The minimums and maximums are. And last example 4 says, we're going to look at how we can read a graph. Divorce rates are considerably higher for couples who marry in their teens. The equation D equals 4n plus 5 models the percentage, D, of marriages that end in divorce after n years if the wife is under 18 at the time of marriage. Determine the percentage of marriages ending in divorce after 15 years when the wife is under 18 at the time of marriage. So, 15 years. Let's look at our graph. So 15 on our graph is right here. And so if we go up, we hit this point here. So we can just look over our Y values, where does that hit, and determine the percentage. So here, D is about 65. So that means about 65% of marriages where the woman is under 18 end in divorce after 15 years. And that concludes this section.